In this video, we're going to look at logarithmic functions and their graphs. This is section 4.2. So a logarithmic function that has a base a. So if y equals a to the x power, and a is greater than 0 and not 1, and x is just a number, then we can say x equals the log base a of y. So exponential and logarithmic functions are inverses of each other. So if you want to change from exponential to logarithmic form, there's this nice little graphic I'm going to draw for you. So you have log base a of x. If I can write, would be better off. X equals y. And then if you want to switch it to y, you're going to have a to the y equals x, then x. So there's that. So it's a nice little graphic to remember how you're supposed to switch between the two of them. We're going to change this first one to exponential form. So we have log base 3, which is a, of x, which is 81, equals y, which is 4. So we're going to say 3 to the 4th equals 81. And then we're going to switch from exponential to logarithmic form. So if I have 5 cubed equals 125, that means that log base 5 of 125 equals 3. So you're just switching them. We'll use that quite a bit. So if you can evaluate them without a calculator by using this change. You can change it to exponential form. So if I wanted to change this, I'd have 4 to the x equals 4. Well, 4 to what power equals 4? The first power. And then this one, 2 to the x equals 1/8. Well, since it's a fraction, it's going to be negative because we want to bring that 2 to the bottom, and then 2 to what power is 8? 3. And then this one, log base 25 of 5. So 25 to the what power is 5. That's 1/2, because you can write it as a square root of 25 is 5. And last but not least, log base 27 of 9, so 27 to the x power equals 9. Well, we got to figure out 27, the cubed root of 27 is 3, so it's going to be over 3. And then 3 to the what power gives me 9 squared. So that's how you can do those without a calculator. Alright, basic characteristics of your logarithmic function. Easy enough for me to say. So your domain is going to be 0 to infinity, so everything greater than 0. X is greater than. So if you remember, like when we did 4.1, the range was the greater than 0 part, and your domain was all real numbers. So with their inverses, those switch, the x's and y switch. Your x-intercept is going to be 1, 0. It's always increasing, and as long as it's as long as a is positive. And then it has a vertical asymptote, not a horizontal asymptote this time, because it has a vertical asymptote at x equals 0. It's smooth and continuous. It's 1 to 1, which means it has an inverse, which we know it has an inverse because we already talked about the inverse. And then the reflection of the graph is the exponential function with the same base. And then we're also going to talk about our natural log function. So, but there's all the characteristics there. They're about the same. I'm not going to read them all to you because I'm not going to insult your intelligence. So, evaluating log expressions with a calculator, you're just going to plug it into your calculator. If you have log base 10, so this one has log base, this little 10 there, it's the same as log of x. Log base 10 is just what it is. So if I plug this in, log of 145 is 2.161 when you plug it into your calculator. And your calculator probably has the log button close to the squared button on your calculator. I don't have one in front of me. And then log base e is the same as ln natural log. We'll call it natural log. So instead of log base e, it just makes it easier. And then this probably is underneath of that log button on your calculator. So if you plug this in, you're going to get 3, hang on, I forgot to do this one, 3.174 when you round to 3 decimal places. And then there's some properties of logarithms that we need to know. So if you have log base a of 1, it's going to be 0 because a to the 0th power is 1. And then if you have log base a of a, it's going to be 1 because a to the first power is a. And then the next one, if you have log base a to the x, is going to be x because if you take the log of that number, log base a to the x to the a, yeah, that was hard to say. So if you take a to the log base a of x power, you're going to get x. They're just going to negate each other. And then if you have log base a equals x and log base a equals y, you can drop the logs and say x equals y. And then properties of natural logarithms. Natural log of 1 is 0 because e to the 0 is 1. Natural log of e is 1 because e to the first is just e. The same thing happens with 3 that it does in the logarithms, the same with the natural logs. And then same with 4. They're the same. If you have ln of x equals ln of y, you can drop the natural logs and say x equals y. And then you can use log or ln on your calculator for base 10 or e. So for other bases, we'll use the change to exponential form, and then we'll, graph it that way. So remember when we talked about transformations, this means it's going to go left 3. So it's just going to look like the natural log of x, just left 3 units. So instead of our x-intercept being at 1, 0, just go 3 left. So that's going to be negative 2, 0. The y-intercept is going to be some weird number, but we'll just plug in 0 for x. If you plug in 0 for x, you get 1.09. So basically 1. And your domain is going to be 0. Nope, not 0. I lied. Negative 3 to infinity. And then your vertical asymptote is going to be x equals negative 3. So since this one moves left, that means we're going to have a vertical asymptote at negative 3. Instead of 0 because it moves, because it shifts. And that's a really great picture, but yours should be better than mine. And then, so that's how you do that. And then we have log base 2 of x plus 1. So this 1 here, since it's not in parentheses, means it moves up 1. Up 1 instead of left 1, because if it was in parentheses, it would move left 1. So if we plug in some numbers, well, we need to rewrite this in exponential form first. Let's do that. So y equals log base 2 of x plus 1. So 2 to the y equals x plus 1. So meaning you're just going to plug in, you're going to rewrite it and plug in numbers. Your domain is still going to be 0 to infinity here because we didn't go left or right any. And then if you want to plug in 0 for your x-intercept for y, you're going to get a half. And then there's not a y-intercept because your vertical asymptote is x equals 0. So that's how you do that. And then the last few here, we're not going to do this one. I won't give you one like that, so we're not going to do it. We want to find g of x equals ln of x at the indicated value of x without using a calculator. So if we want to find g of e squared equals ln of e squared, well, the ln and the e cancel each other out, so you're just left with 2. And then same with this one, similarly. That's not really a word, but ln of e to the negative 1/2. The e and the ln cancel each other out, so you're left with negative 1/2. And then since here we have the 1-to-1 property to solve the equation for x, so log base 3 of 2x plus 3 equals 9. So since the logs are the same and they have the same bases, you can drop them. So I have 2x plus 3 equals 9. Solve for x. 2x equals 6, so x equals 3. And you probably should check that, but I promise it works. And then same here. Since you have natural logs, I can drop them. And then move everything to one side. So I'm going to move these guys over here. I'm going to move those over there just because it's easier to keep my x squared positive. And then you can use quadratic formula, but I'm going to factor it. So x, 1 and 2, and negative 2 and positive 1. And then x equals negative 1, and x equals 2. If you plug them back in, this one's not going to work. This one works only. So that's how you deal with logarithmic functions.